Okay guys, so we're back.
See Avatar?
Last time we're already done with the programming stage, so I made a few tweaks. Let me describe them what I did. Well, first of all, I just print the solution instead of returning it. Here, I really have a problem with the recursion. For some reason, it prints 200 and it looks weird to me. And so I understand there's a problem. Let me think about the problem. Let's see. Okay, so right now what it's doing is basically as soon as it gets to 0, it returns 0, and that returns the solution as a whole. Let's think about it more. Okay, so I'm moving this away. Okay, so it turns 0, turns 1. So that might actually not be the way.
Actually, gonna put an else here.
Okay, every time it gets down to 0, we should add 1, I think. Right? Yeah, 1.
Since we're only dealing with two-digit numbers for tens.
And we know it's not going to do the same thing that we don't know, that we can't know. That's not good. Right, yeah. Okay, let's rethink about this. So we're starting with 200 and we're decreasing different amounts, right? Right, yeah. That's what we're doing.
39 should give us back.
So what we should be doing
Let's see what we get.
is just look at the 200.
Great.
Let's think about 10. Okay, for example, 10, right? So you can do 10, that's 1. Now you can do 5 and you can do 5, right? And 5, you can try all sorts of stuff from there.
What about 77?
Right? Okay, so 10 is 1, you're done with it. Now,
77
it's
is
5.
7 and 5 is 12. Good. Okay, good. So my 10th method works.
Okay.
The next step is
So,
the 100.
5.
Now when you put in 100, you get
So let's say
the
5.
number, then 100,
You do 5.
then and then the tens. So you have
Okay.
You can ask questions, you can ask.
Let's see, when you do 5, right?
so you have
You can just subtract
say 3 and the number
5. Okay,
100.
recursive method is
then
definitely a solution. Let me
and then
just
your number of
rethink it.
tens, as it is here. 115.
For 10, you're going to have 10, you're going to have 5, 5, you're going to have 2, 2, 2, 2, 2, right? And you're going to have 1, 1, 1, 1, 1, 1, 1. Right. So maybe there's actually a better way. Let's rethink about this.
So
Okay, so we're taking a number, we're looking if the number of possible coins is less than the total,
10 letters
right?
added
And
to
then what we can do
So I'm going to make my
is we can basically, yeah, okay. So I have a better idea, I think. We can see how many coins fit in total. So for example, we're going to go through the coins. Okay, 1, it could fit in 200 times, right? 2 could fit in 100 times.
Yeah, 4 iron range is
5 is going to fit in 40 times.
CH and nums is a
Coding back is a function.
And what?
Coding back is a kind of page with.
but if you have
Okay.
for this so yeah.
Wow, that's pretty crazy.
You know, for each loop,
Cursive is the only solution
It's kind
here.
of a for each loop.
Let's rethink this.
Make an array.
Mm.
Okay. You do a while though.
Yeah,
Wow,
whiles are much
they're
more
frustrating
useful in Python, I find.
Yeah, I think.
But if you have an array,
Nice one.
for loops are great
Because it's just
because it's just right through, and the incrementation isn't too difficult as
It's a
well.
bit like the for each loop.
It's basically a for each loop
Yeah.
because the instance variable impersonates
Okay.
each element as you go through.
Right.
Where's
It's on hundreds now. So
Let's see again.
probably when I'm on 398.
Okay, so yeah, getting a little problematic right here. Okay, so I'm thinking how to record. First of all, I have to make sure the solution is different, right? It's it's not so easy.
First of all, this is what I'm going to do. I'm going to say R equals n mod 100. And that's going to give me a number between 0 and 100, which is going to use my tens function. Okay? Then I'm going to say
Okay,
n
first of all,
n minus r.
hmm.
So now n is a whole number.
let's say we have 100 and 100, right? And then we split the 100, one of the hundreds to 50-50. Now that adds 1, right? Like all the different combinations. That's just adding them. So you know what we can do? We can actually split it.
Then what I'm going to do now
We
is,
can actually,
I'm going to
we can
divide
actually
that
just
by
split
100,
it.
So I just have a unit.
So we can start
N
coins.
equals n divided by 100. So now what I can do is I can just return units n plus 10 for 100 and plus
Damn.
tens of all.
Okay. Ain't thinking here.
Wow, that was really much easier than I thought it would be. Okay, cool.
Coins,
So I'm going to go ahead and
coins.
print
Total.
hundreds of 342.
Alright, so back right now.
Let's see what goes on.
So before I go on, I was looking at the preview of the
23. Yes. Alright, 115. Let's do it.
Okay, so I'm looking at ways maybe converting. Say we split 200 into 100 and 100. How can we convert each one of them to
Since I
any
have a
others
ton
of the coins?
I'm going to
Let's
how many
see.
letters are used in total? Aha. Here's what I'm gonna do.
Well, not really sure.
Def do it.
Let's think.
I like to call my
So,
my last method.
I'm
What I'm gonna do is a lot of printing in between, just so that we can keep track of what's going on, kind of real time as we do it.
You know what we should think about? We should think about it like this.
We're gonna need
We should,
tracking button.
you know,
I need
we
to
should.
keep the number hundreds and something that's less than 100.
I have an idea. Okay, so we're gonna take 200, right? We're gonna subtract each number from it, so it's gonna be 50, 20, 10, 5, 2, 1, whatever, 100, yeah. And then we're gonna look for different ways of expressing it.
Why is that? Because of the 100 and.
all the time until it finds
3 mod 100
a number
is 3.
that is greater than
Oh, I know what I'm gonna do. I know what I'm gonna do. Okay, here's what I'm gonna do.
right. So the last part, the previous part,
I'm gonna do print do it.
we had an error.
No, not print do it. Def do it. Do work.
Pretty tough, actually.
So I realized what
Great. So I'm gonna have a tracking
200,
value
100,
and it starts at 1.
50, 20, 10, 5, 2, 1. Okay, so 200,
I'm
subtract
gonna have my
100,
sum.
right?
Sum starts at 0.
so
Then
27.
I'm gonna do a while. While n is less than 10.
Okay, let's think about different ways of expressing 5.
Sum
You can do 5,
plus
right?
equals
Then you can do 1,
hundreds n
1. Well, 5 times 1.
and also n.
Yeah. You can do
So
2,
then
2, 1. You can do just 5, right? And then, for example, 5, you can do just for 10. You can do just 10. You can do 5, 5. You can do 5, 2, 1. And you can do 2, 1, 2, 1. You can do 2, 2, 2, 2, 2, 2, 1, 1. And you can do all the ones, which 2s. Okay.
Then I'm going to do while
should return 144. Alright.
while
Okay, let's see.
Sign
See it
n
again.
is less than 1,000.
50.
I'm going to do the same thing with hundreds.
Each one of them can be expressed in terms of themselves, right? So, for example,
And
2 can be 1,
then return
right?
some. But I just
So
realized that
it's just
1,000 is
twice
one of the
2.
values.
And
Doesn't
then
make
5
sense
can
to
be
do
2,
anything
2,
anymore,
1.
so I'm just gonna
Or it
add
can
an
be 5
example.
ones, right?
8,
Okay, so that's a good
11
way. That's a good way.
ones.
Just to
I'm gonna
think
start some at
how others can be expressed. Okay,
So
I'm gonna
I'm
think
gonna print
how many.
n.
Okay, okay, so here, this is what we're gonna do.
I'm gonna
We're
print
gonna do,
n
we're gonna make
sum
ways of expressing, okay?
because I can.
Ways of expressing. We're gonna make this array, okay? And for each value, we're just gonna enter, manually. We're gonna think how many ways we can express each one, and then, oh no, actually that's getting a little tough. Okay, so we're gonna make a method. Def ways of expressing.
No, this is
Add a
obviously much
certain
more inefficient.
point.
But I just want
Yeah,
to
just
keep track
a
of
single
what's going on.
Okay,
And if I see that it's working well,
and we're
and
gonna
that it's
put
taking a long
coins.
time just
Okay,
because it's printing so much, then I'll
Good.
take out the prints and do
So,
it again.
coin.
But I
We got all the
kinda like
coins,
doing
and we got
especially
a
on
certain
smaller
coin.
methods.
So
So just in order
Because it's nice to see the progress.
we can
I actually run foo, which is what it does here. I'm just gonna run
Cool. I'm pretty sure
okay,
this
so
is
we're gonna make ways,
12, which
Can we just do it?
as the question state,
coins.
what, 12 should return 144. So I'm gonna test
here we
if
go.
that actually works. So
Okay, well we're doing the hundreds, so this is not going to take long at all.
5.
Yeah, so the way to think about it is how can you express each one, right? So
I think Q30 might be the next number, so I'm gonna try and run F11 here.
so ways,
3, 7,
for example,
6,
so
and
okay,
about 2 minutes later.
so ways. You start with 0, right? Now
I really hope this works.
So let's try to run F11.
Pretty sure we're at 500. 600.
okay, we're
This
gonna
will have about 40
take
minutes. Think about
coins
efficiency.
less,
Maybe about setting how it can be implemented.
less,
But
and
who knows right
we're
now?
gonna call this function.
My clock's on
Okay.
it's time, so
What it does is it takes the coins, takes the value of our coin, right, which is a num, and finds all the coins that are less or equal to.
Okay.
Okay, so we can go to each one and just subtract it.
So the number should be
It's a little complicated right there.
2105,
A little complicated, I have to say. A little complicated. Because how do you avoid cases? You can do 2, 2, 1 and then 2, 1, 2. So I have to think about this. Don't work repetitions and stuff.
Oh, okay.
Okay, let's try to run this right now and then
I'm stuck on a sentence.
I'm gonna run it to 12.
Okay, you know what? So we're gonna start manually. We're gonna start the manual way. You know, let's leave this method out. Let's not take it into consideration. Let's start the manual way. See what we can get from there. Ways of expressing.
Okay, we're back.
Okay, this is 1, 1. 2. You can express in 2 ways, right? 1, 1, and 2. 5 you can express in 2 and 3, 5 ones. You can do 2, 2, 1. You can do 2, 1, 1, 1, 1. You can do 5, right? So that's count 4. It's 1, 2, 3, 4, right? Okay, 10 is basically 2 times 5, right? So it's 5 and 5. And each one you can express 8. Okay, so it's 8. Okay, good. 20. 20 is 16. Okay, 50 is gonna be 32. Okay. 20. Let me think about this again. Yeah, looks good. 20. Is 10 gonna be okay? Let's do 2, 2, 1. Yeah, whatever. Yeah, so it's 4 times. No, it's 4 times 4.
100.
Is it? Yeah, it's 4 times 4. Wait, hold on. I got everything.
Just kind of
So I can do 5 and then 4. 4 operations, right? And then we're gonna have different way of expressing 5 in there, 4 ways. So it's 4 times 4, so it's 16. Then this becomes 32.
Nothing. But it gives you
I accidentally killed the Java task that was doing my screen recording. Right, so I'm gonna defer doing it. I've only been 2 minutes through it, so it doesn't.
And the
Okay,
reason
let's
is,
see.
for the ones that are 100,
2, 4.
so say if R
This
equals
makes
0,
sense. 1, 2. Yeah, this makes sense.
equals
1,
0,
2, 3,
then-
4. Yes,
which
this
is
makes
calculated
sense.
like 300 mod 100, right?
Okay, I guess that can make you can make a case
If
about
that
this.
equals 0, then
Okay,
all you're supposed to do is
32.
the units plus 100.
Alright, so I actually killed the.
But now let's
Okay,
print
so
10
can we make
40.
50 into simpler cases, right? We're in 50 already. 1, 2, 3, 4, 5. Yeah, we're 50. Let's think about making it into simpler cases. You can make it 20, 20, 10.
Okay.
Okay, and you can just multiply them, right?
If R
20, 20, 10.
Accidentally,
then
4,000? Ouch, it's a big number. It's a big number.
units
Okay, we're gonna stop here and we're gonna continue
is an array.
in another segment, I guess.